Hello everyone, we are Bitnine and we are glad to have this opportunity to introduce our new visualization tool, AgensBrowser. This application enables users to more easily understand graph data by providing a graphical representation that users can interact with. GraphDatabase is a database that uses the graph model to represent and store data based on nodes and edges. The data flowing from the real world contains complex relationships, especially in business. With the need to represent and understand relationships across data more easily, we increasingly have a common need for graph databases to replace the traditional relational databases these days. AgensBrowser is the database client that connects to AgensGraph, our graph database product. You can query and visualize graph data by using Cypher, a dedicated graph query language. Exploring data by visualizing is one of the most intuitive ways to understand the data correctly. You can write queries to return and visualize your data, to draw new insights and examine connections. As you know, to effectively explore the graph data, there needs to be a specific purpose. Generally speaking, the data produced by traditional relational databases may not adequately show connections between data points that businesses may find valuable. Let's say that we have a customer here named Anton, and the problem we want to solve is that Anton's purchase data is only related to the purchase history of what he has already bought in the past. So if we want to know something like which product we should recommend Anton in the future, we need to understand the data from a different perspective. For example, let's define relationships between Anton and his favorite products based on the assumption that Anton prefers products that he frequently buys. Let's say that we have another two customers, Elizabeth and Carl, who have similar purchase histories to that of Anton. We can define the relationship between Elizabeth, Carl, and Anton based on the similarity between their purchase histories. We can create a graph with business relationships and can now recommend new products to Anton through Elizabeth and Carl's purchase histories. The graph represents business relationships by combining and modifying various relationships around Anton, and we can explore more other examples with ease using AgensBrowser. Now we are going to look at the sample dataset Northwind. We are going to use Northwind to make a graph containing business relationships for simple product recommendations, specifically for Anton. The sample graph data Northwind has 6 vertices and edges each, or 6 types of vertices and edges each, and it has 91 customers, 830 past orders, and 77 sold products. We can visually understand this by using the metagraph. On the main page of AgensBrowser, we can see the connection information of the graph database and the metagraph. The metagraph explains relationships in graph data. And here we can see the customer vertex is connected to the order vertex, and the order vertex is connected to the product vertex, and the employee vertex who sold the products. The supplier vertex and the order vertex is connected to the product, and the product vertex is connected to the category vertex and is grouped by it. If we want to check how many products are included in orders, click the orders edge connecting the order vertex to the product vertex. We get this information from the quantity property value on the properties label panel at the bottom right of the screen. We can create or delete label types of the vertex or edge through the dialog boxes on the main page. Next, we are going to look at the query page and execute graph query statements from there. We can see the editor panel where we edit our query statements. On the panel named Graph Result, the visualized result of the graph is presented, and the Table Result panel shows the results in a table format. Each product can be saved or loaded by using project management functions. I'm going to load one of the saved projects. In this project, there are customer, order, and product vertices, and for edges, there are purchased and orders edges. Every project does not include the table result because the volume of the saved data could be too large. Let me execute these query statements to view the table. We can check the result of the table query statements to see the object type data on the table result panel, and also copy the data into the clipboard. And now we can start exploring the Northwind graph. First of all, to figure out the overall shape of the Northwind purchase data, we need to execute some query statements to get some part of the purchase relationships. The execution result shows the graph of 120 vertices and 138 edges. The coast layout is applied to this graph as the default layout. There are customer, order, and product vertices, and for edges we have purchased and orders edges. And I'm going to separate some of the vertices and edges from this graph by their label types. If it were a relational database, we would probably see several tables like customer table, product table, and etc. This table representation of data is not good enough to get the whole picture of purchase relationships when we need a better visualization of it. But the graph model can offer a better visualization for this entire view. Let us apply some other layouts to the graph and separate some part of purchase relationships from the original graph. Apply the Coast 2 layout to the original graph and change the style of the labels for a nicer look. Increase the size of customer vertices who are located in the center. And change the color and decrease the size of the order vertex. Well, now it looks more readable. Next, let's select a cluster of vertices from a single vertex. To select a vertex cluster, first we set the selecting criteria as 3 hops maximum, not including vertices with the same edge label. If we click a vertex among members of a selected cluster, more vertices are added to this cluster. If we only want to visualize the selected subgraphs, just right-click at the blank area of the graph result panel, then we will see a pop-up menu. Click the Hide Unselected button in the pop-up menu and apply the dagger layout to this subgraph. We are now able to grab the entire picture of the purchase relationships completely, even though this is only a small part of the whole data. Next, we will export a screenshot of this graph, including a watermark, to an image file. Here we have our desired image file. And I'm going to save it as a project too. Next, I'm going to look up Anton's purchase graph alone. Let's apply some structured layout to this graph. Agents Graph supports the expansion from specific vertices to connected vertices of the different label types to help users understand the data more easily. The maximum expansion output is 20. Next, we will identify sales staff per each order by using the expansion function. The product can have expansions to the supplier, category, order, and customer vertices. This means that for a product vertex, we can find who supplied this product, which category it belonged to, which order it was included in, and who bought it. The category vertex can only have the expansion to product vertices. Now, let's simplify the graph by inserting a new edge called rated to look at the relationship between the customer and the product more effectively. I've just made the rated relationship. The rated edge has properties like total count, order count, and rating. With the rated edge, the relationship between the customer and the product is presented except the order vertex. Next, we will look at Anton's purchased product ranking. If we look at the table on the table result panel, there are product names sorted by rating, the ratio of the number of a particular product purchased to the total number of purchased in descending order. Now let's use the rated edge to find out who actually bought the same products as Anton. Here, I'm going to fix the location of Anton and apply a layout again. We can see Catherine has bought 4 of the same products as Anton. And likewise, Maddie has also bought 4 of the same products as Anton. And they may be our target customers who actually have the similar purchase pattern to that of Anton. Based on this assumption, we are going to get the cosine similarity between customers by using a cipher query. We will use the cosine similarity to estimate the similarity between one customer's purchase ratio to another's. And the higher the cosine similarity is, the more similar the purchase patterns are to each other. To get the similarity edge, First, calculate the inner product ratio vector of both customers and divide this inner product value by the outer product result. We get the outer product value by using the rated edge. And then calculate the inner product part and divide it by the outer product value. Okay, now that we have the similarity edges between customers, let me show the top 5 customers who have the most similar purchase patterns to that of Anton. The similarity score of the customer with the most similar pattern is 0.41. The product that will be recommended to Anton is chosen among products that were not yet bought by Anton and also preferred by customers who show similar purchase patterns to that of Anton at the given moment. Here, the support ratio of recommendation for the candidate products can be derived from the average of similar customers' purchase ratio value. We will call this average as the recommendation score, and output 100 recommendation scores for Anton sorted in descending order. The recommendation scores of the top 4 recommended products are all over the 0.05 threshold score. The customer IDs who support the recommendation result are displayed in an array below. Next, I'm going to show you how to generate the same result as the edge called recommend instead of a table. I'm going to make new relationships with the label recommend for Anton for the products whose recommendation scores are above 0.05. I will visualize customer vertices with the similar purchase pattern and recommend edges. Similar customers may have a common pattern. For easier identification of recommend edges among other edge types, let me change the label style. Next, we will apply a different layout to the graph based on Anton. The customer shown here might have some similar patterns or features to those of Anton. From the graph, we can see many customers are clustered around each recommended product, and therefore it is easy to identify which customers are closely related to which specific products recommended. If it is possible for us to capture some specific patterns or features by investigating those customer clusters, then we may uncover some unknown rule or hidden characteristics about our customer, product, and even the business itself. Like what we've done here, as we keep exploring data by querying and visualizing it from many different interests and perspectives, it can definitely bring us a more deeper and sophisticated level of understanding of our data. Thanks for watching this video. This was an AgensBrowser tutorial, and if you have any questions, feel free to contact us at www.bitnine.net.